because if I remember right, we learned about matrices in Algebra 2, right? Okay, so you're going to help me with today's lesson. Can you handle that? You know about matrices? You can help me. So, if two matrices are equal, what are they going to look like? The same. Can you be more specific, Tiny? Ah. Corresponding matrices are equal. Okay? If two matrices are equal, then all of their corresponding entries are equal. Same order, same entries. Okay? That might seem pretty obvious to you right now. But if I give you two matrices that are equal and there are unknown pieces, you need to be able to use the fact that corresponding entries are equal to maybe solve for some unknown values. Okay. Matrix addition. I think some of you already kind of spoke about this when we talked Monday about matrices. If we are going to add matrices together, what needs to be true about their order? What? So you just described multiply, right? You said the word multiply. So say that. Say that. Yes. Okay. We can add matrices together if they have the same order. Okay. What happens if they don't have the same order? What happens? We just say it's undefined. Okay. If you try to add matrices that don't have the same order, you would just tell me that the sum is undefined. Okay. Okay. So turn to your neighbor and describe to them the process of how you add two matrices together.
Right?
Add what?
Entries.
All right, how do we do it? Pod 2, what did you say? Oh, you guys are using the best vocabulary. We add matrices by adding corresponding entries. Good. Okay. Same would go for subtraction because subtraction and addition are equally related. Okay. Now, we can also multiply by a scalar. So, as we're going through this, anything that's a matrix, we're going to name a capital letter, like your calculator. Okay, so when I write lowercase c, capital A, lowercase c is like a number, 5, 4, 100, whatever, and A is a matrix. Okay, so if we have a number and we multiply it to a matrix, we're just going to take that number and multiply it to each entry. examples. Sound good? All right. By the way, I did bring my leftover Halloween candy as I promised. So just get through this lesson. We didn't have very many trick-or-treaters last night. It was a little chilly out. Okay, go ahead and write these two matrices down. We're going to do a variety of calculations with them. It was snowing when we were walking around. You know, I dressed up with my kids for Halloween safe night when we came trick-or-treating here. But last night I was just going too long. So,
You had a bunch of parents driving the kids around.
yes. Yes.
I thought it was a teenage.
I couldn't do that because my kids were Captain America and Spider-Man and their costumes had like bone muscles inside. And so they were afraid we couldn't strap them in the car case. Okay? To find A plus B, you told me we need to add corresponding entries. Let's go ahead and do that. Naming the entries in each row, I have 4, 2, 4, -2, -4, 2, and 1, 4, 4. I feel like that. Okay? Some of you are like, oh my gosh, this is easy. Just take your time because this is not the problem that you want to miss points on your quiz or test because you were going too fast and you added incorrectly or you wrote down a number incorrectly or you missed a negative sign or whatever, okay? So just be careful. -2b. Oh, I can't even see b right now. If you have a number multiplied to a matrix, we are just going to multiply each entry in that matrix by that scalar multiple. So, -2b, we're just multiplying -2 to each entry. So, -4, 0, 0, -2, 8, -6, and 2, -6, -4. By the way, what is the order of A? 3 by 3. What is the order of B? 3 by 3. Okay? That's probably something I should have said way at the beginning. What is the order of A and B? They're both 3 by 3 matrices, so we can add them together. Okay? We got a little excited to do our calculations there. Okay? Lastly, I want to calculate what positive 3a minus b would be. Okay? Now, some of us are going to try to do this in our head all at once. It would be my suggestion to do one operation at a time. So what I would probably do is I would write 3a out as a new matrix and then write minus b next to it in order to be able to make the calculation. So 3 times a, we would get 6, 6, 12, -9, 0, -3, and 6, 3, 6. Okay? And you can do one of two things. You can multiply b by a negative to add them together, or you can write it as a subtraction problem. Okay? But I have 3a written out. I'm subtracting b. I rewrote it just next to it so I can subtract the entries. So we have 6 minus 2, 6 minus 0, and 12 minus 0. Negative 9 minus negative 1, 0 minus negative 4, and negative 3 minus 3. 6 minus negative 1, 3 minus 3, and 6 minus 2. All right, so now the rest of class we're going to work on matrix multiplication. Okay? Caleb, you were trying to explain to me matrix multiplication, and what do you remember about the orders?
The number of columns in the first matrix has to equal to the number of rows in the second.
That is exactly right. Okay? If A has order m by n, and B has order n by p, notice how the columns in the first matches the rows in the second. We can multiply them together, and then the product is an m by p matrix. I'll go ahead and give you a chance to write that down, and then we'll talk through it a little bit more. So you always want to determine the order of your matrices, okay? If A is an m by n matrix and B is an n by p matrix, we need those numbers right there to match. The columns in the first, rows in the second. If those match, then yes, we can take the product, and our resulting product will be the order of what we have on the outside, m by p. Okay. Why does it work out like that? We do what's, to multiply matrices together, we do what's called row by column multiplication. That is what I would write down from that paragraph right there. Okay, we're going to do row by column multiplication. Now the rest of that paragraph I would not take the time to write out, but I'm going to explain it to you. Okay, we're going to take what they describe as the ith row and the jth column. That product of AB is obtained by the entries in the ith row of A corresponding to the jth column of B, and you're going to multiply and add together. Okay? I think that's a very confusing way of saying it. Okay? And so I want to do this by example. Now, luckily for you, you've done this before. Okay? So I'm not sure how much detail I'm going to have to go into. But we're going to multiply these two together, so I'd like you to go ahead and write them down. Okay? Since the columns, the number of columns in the first match the number of rows in the second, we're going to be able to pair up values to multiply, and as we do that, we'll add them together. Okay. Now, in that second matrix, matrix B, I did highlight blue and red so that you can see the difference between the columns. Okay, so we're going to obnoxiously write every step down. Okay? But I just want you to be able to see what's happening. All right? What is the order of A? We have a 3 by 2. And the order of B is a 2 by 2. So since those two numbers match, we're good to go. And our result is going to be a 3 by 2 matrix. Okay? So, here we go. Row by column multiplication. We are going to take the first row and multiply it by the first column, and that's where it's going to go in your matrix. So what we're going to do is we're going to take -1 times -3 and 3 times -4. We're basically going to rotate this row to match up with these numbers in the column, and we're going to multiply them together. So the first entry times -3 and the second entry times -4. And that goes in the first row, first column. Right there. Then we're going to take that row, and we're going to take first row times the second column. If we're taking the first row times the second column, then that number is going to go in the entry in the first row, second column. So we take the first entry times 2, the second entry times 1, and we're going to add those products together. Okay? Once we've taken our first row and we've multiplied by all the columns that we have, then we're going to move on to the next row. Okay, so if we multiply second row times the first column, that's where it's going to go. So second row, first column goes in the place, second row, first column. We're going to take the first entry times -3, the second entry times -4, and we'll add those two products together for a number. Then we're going to take second row times the second column, and we're going to rotate these numbers so they pair up, 4 times 2 and -1 times 1. And since we're taking second row times second column, that entry will go in the second row and second column of the product. Okay. Like I said, we're annoyingly writing down every single step. You don't have to do this when you go to do the real thing, okay? But just want to remind you of the process, all right? So then we're going to move to the third row times first column, which is where that entry will go, third row, first column. Pair up, first entry times -3, second entry times -4. Okay, and then the same thing for third row, second column. That's where it will go. First entry times 2, second entry times 1. Okay. Now, what I foresee happening is you being able to write down, like what I would more expect is to see 3 plus -12, and then you reduce it down to -9. Or -2 plus 3, and then your next step, you reduce it down to 1. I would not try to do everything in your head, because if you do make a mistake, it is nice to come back to your work to try to figure out what happened, okay? But that is our process, okay? Give me a thumbs up if you definitely remember this process from last year. Awesome. Please write down A and B, and we're going to find their product. So write A and then B. I'll give you a moment to write them down, and then I want to talk about their order. What is the order of A? And what is the order of B? It's a 3 by 2. Can we multiply A and B together? Okay, these numbers right here match, so we can multiply A and B. What's going to be the order of AB? AB is going to be a 2 by 2 matrix. Okay, all right, so I think it's a good idea to show a little bit of our work here, all right? But let's take the first row times the first column, and we are going to take these products to add together for one entry, all right? So we're going to take, I need you to help me out. 1 times -2 plus 0 times 1. I should not only hear one person. 3 times -1. Okay. So our first entry would be -5. Okay. First row, second column, that's going to go right here. All right. So we're going to pair these up. 1 times 4 plus 0 times 0 plus 3 times 1. So our second entry in the first row would be 7. Okay, now we'll move to the second row, first column. We have 2 times -2, -1 times 1, and -2 times -1. What's that entry going to be? What? Negative. And then second row, second column, we're going to have 2 times 4 plus -1 times 0 plus -2 times 1. So that entry is 6. How excited are you if you have a 0 in your matrix that you're multiplying? Okay, helps with the multiplication. But you know what happens a lot of times? A lot of times people forget that when you multiply by 0, you get 0. Okay, so don't make those, be careful, take your time so you don't make those silly mistakes. Okay? Really, on the matrix quiz or test, it's either you make a lot of really tiny mistakes, like mismultiplying, misadding, or you have no idea what you're doing. Okay? That's kind of how it gets graded. All right? Now, turn to your neighbor. Is matrix multiplication commutative? All right, Callie, why is it not commutative?
Because it's based on the order. So, like, if you have a 3 times 2 times a 2 times 2, you can't just flip it. Because then you have a 2 by 2 by a 3 by 2, and they're not the same.
Okay, so we decided, will you remind me, what was the order of A?
2 by 3.
It was a 2 by 3, and B was a 3 by 2. And so we got the resulting was a 2 by 2, right? Well, if we take a 3 by 2 times a 2 by 3, we can multiply them together, but what's our result going to be? It's going to be a 3 by 3. Okay? There are even products that we can't even take. Okay? If this was a 2 by 3 times a 3 by 3, we could find AB, but we couldn't even find BA. All right? So matrix multiplication is not commutative. Okay, I am going to give you 2 minutes for you to find me the 3 by 3 matrix of B times A. 1, 2, 3, go. Compare your answer with your neighbors. Eli, what'd you get?
6. 1, 0, 3, 4, negative 1.
This is Eli's answer.
I didn't really know because I looked at them in my head. I didn't really Yeah. So I just did the wrong way, which caused a little bit of problem. Well, why even negative 2? Negative 2.
Oh,
Okay. You guys get over there?
Mine was that, except it's like backwards.
Back.
Like I got all those numbers, but in reverse. Mine didn't.
Okay. So make sure, like, when you're taking, do you take the first row? Oh.
There's
Why did you do it?
Okay, so since you,
When? Yeah.
I thought it was
Like, did you
B10.
report to
it is B10 day, but when you take first row times third column, it has to go in the first row third column. Does that make sense? So just throw it right there. Okay.
They give you a time.
Typically, they're going to be written like next to each other instead of like you had them written like this instead of like this. You see what I'm saying? Okay, what I'd like you to do is write down this table right here. Write down this table. It's an equipment list for softball teams. Okay? When you get to be an adult, play softball instead of baseball. Some adults play baseball for their career. Okay? But softball leagues exist for adults. Okay? So I have a men's team and a women's team up here. They have bats, balls, and gloves. Now, each bat costs $80, each ball costs $6, and each glove costs $60. Now, we know how to calculate the total cost for each team, don't we? We need to take our equipment, how much we have, and multiply it by the individual costs. Do you agree? Okay. So what we're going to do that with matrices. Okay. So this is basically giving you a rectangular array of numbers, isn't it? Okay. We can write a matrix that represents, and I'm just going to do this really lightly in green, bats, balls, and gloves for women's and men's teams. Now, I want to know how much it costs for each team, right? So we have some information about cost. We can basically make a matrix, either a 1x3 or a 3x1 matrix, of how much it costs for bats, balls, and gloves. This is a 2x3 matrix. Do we want to create a 1x3 or a 3x1? We want to create a 3x1 matrix so we can actually multiply them together, right? If I create a 3x1 matrix, oh my gosh. Yeah, it is. I was just going. So let's try that again. We had a 3x2 matrix. So do we want a 1x3 or a 3x1?
1x3, and then can you multiply it like 3 times 3?
Okay. I have a set of 3 numbers that we can make a matrix with. So if we create a 1x3 matrix, we would be able to multiply them together. Now this is cool. So we have, I'm going to write 80, 6, and 60 for our matrix, right? And what does that represent? That represents the costs of bats, balls, and gloves. So do you see how when we do the row times column multiplication, the bats, balls, and gloves, they match up, right? Okay, that's going to happen. All right, so we're going to end up with a 1x2 matrix that represents the money for a women's and a men's team. Okay, so for this entry right here, we need to take the row times the first column, so help me out. What is 80 times 12 plus 6 times 45 plus 60 times 15? Then we're going to take row times second column. Help me out. 80 times 15 plus 6 times 38 plus 60 times 17. the men's team does cast. Okay, so this is just a way to take a rectangular array of information, right, and actually use it as a matrix to do the multiplication. Okay, we just had to put some thought into what kind of matrix do we need to write in order to be able to do the multiplication. Okay, so I want you to notice that when we multiply, those labels right there would match up. Just in time. All right, you have some homework. Hopefully, it feels